Hello, everyone. I'm Elizabeth. Happy to be here today to talk about our work over the past few months, where we look at software composition analysis tools. And hopefully by the end of this talk, you'll learn how to better integrate these tools into your software development pipelines. All right. Before I dive into software composition analysis, a little bit about myself. I completed my bachelor's in computer science in Taiwan. And then after graduating from that, I joined the WSPR lab at NC State as a PhD student. That was back in 2022. And this has been my third year in the program, and I've had the opportunity to work on various security and software supply chain projects looking at SBOMs or vulnerability fixing commits or vulnerabilities in VS Code extensions. At NC State, we have a Secure Computing Institute, which our lab, the WSPR lab, is part of. Our lab does research broadly in the area of security and privacy. We also have research implementing qualitative methods, research on networks and telecoms, crypto, and also research combining software engineering and security. And one of the main focuses of research in our lab has been on software supply chain security. So we have a secure software supply chain center effort across multiple universities where we try to improve the security posture across the entire supply chain. Our lab also does various outreach programs like cybersecurity camps for students or industry conferences like NC PACE, which will actually be happening right here in the same conference center next week. All right, so let's dive into software composition analysis, or SCA. From a show of hands, who here has used SCA tools? Okay, I see a lot of hands, more than I expected. What has your general experience been with the tools? Yeah. What has your general experience with the good? They've been good. Lots of warnings. We'll dive into other experiences other users have later in the presentation. But let's take a step back and look at why SCA tools. So there's a lot of different security tools out there. You have ones that look at your containers, packages, or static testing, dynamic testing. But what sets SCA tools apart from all the other tools? So I like to think of SCA tools as the tools that focus on your external libraries, code that's imported from someone else. And because you don't understand the code, you need tools like SCA tools to help you identify risks or vulnerabilities in them. So for those who are less familiar, I want to use the log4shell incident to motivate you on why we use SCA tools. So this is everyone's pretty familiar with this incident. This happened back in 2021. A zero-day vulnerability came out in the log4j library. And when this happened, all the different teams, organizations, they had to scramble to determine if they were using a vulnerable version of log4j. You could be importing it directly in your direct dependencies. You could also be importing library A that imports library B, and that imports log4j. So the vulnerability could be somewhere in your dependency tree. And that's where SCA tools come in. They'll look at your entire dependency tree and determine if vulnerabilities exist in them. And even to this day, if you run an SCA scan, you might still be able to find vulnerable versions of log4j in your application. So we want to prevent incidents like this or react quickly to incidents like this. So let's take a look at what an ideal SCA would be. So I've listed 4 characteristics here. The first one being, I think, an ideal SCA tool should be deployed smoothly. You don't want to have to go through too many configurations or set up challenges for it to integrate smoothly into your development pipeline. The second thing is it should identify components correctly. Depending on the language or ecosystem the library is in, dependency trees can grow really, really large. So you want a tool that identifies components correctly, because you wouldn't want the tool to identify like a ghost dependency and telling you there's a vulnerability in that. The third characteristic is it should identify vulnerabilities in them, but only alert you on the ones that matter. So for example, in the diagram here, you have CVA, F, and E. But say you use CVE in a way that wouldn't affect your application. Ideally, you want the SCA tool to recognize that and only alert you on A and F. And then once you get those alerts or vulnerabilities, you want some fixed suggestions from the tools. And those fixed suggestions should be actionable suggestions that users can actually act on. So these are 4 characteristics I listed. Let's take a look at what running an SCA tool looks like. So I forked a random GitHub repository into my GitHub account, and I ran a quick SCA scan on that. The first thing I noticed after I run the SCA scan is there are multiple different results, and I was a little confused by that. But say we take a look at the first package.json file. So I click on that, and then I go into all the alerts, and there is an overwhelmingly large number of alerts in here. There's probably hundreds of critical alerts, even more high alerts, medium alerts. And there's a lot more. This is just like a portion of the SCA scan. I screenshot it. So there's probably a lot more low alerts down there. So I look at this and I'm pretty overwhelmed as to what I should do. But say I take a look at one of the critical vulnerabilities in Babel Traverse. So the text probably isn't too clear here, but I take a look at the overview and notes in here, and it says you're vulnerable if you use certain methods, and you're only exploitable if attacker does something. So I'm a little confused by the statement because I'm not sure if I'm vulnerable or the vulnerability could be exploited in my application. So then I think maybe some more CV information would help. So I take a look at the CV information, and it pretty much gives me similar information saying, if you use certain methods like evaluate, then you might be impacted by this vulnerability. So then to determine if I'm actually impacted, I go back and I look at the paths that lead to this vulnerable library. And there's so many different ones. Again, this is just a screenshot, a portion of all the different paths listed. And I see this library is actually a transitive library that's introduced by some other direct dependency React scripts. And to fix this, the tool gives me multiple different suggestions. You can update to version 3, version 3.4.1, and there's so many different suggestions. I'm not too sure which one I should update to, or should I just update to the newest version? And this is a simpler case. There could be other cases like this one, where a vulnerability is also in a transitive library. And this transitive library is introduced through 3 different direct dependencies. So should I update all 3 of the direct dependencies? Will that cause some kind of incompatibility issues in my application? And all of these were just experiences that I went through when I ran a quick SCA scan. You guys here might have run into other experiences, more complex experiences. And we really wanted to understand what challenges users run into when using these tools. And to do that, our approach is to conduct a user study where we try to answer our 4 main research questions. So we structured the research questions with a top-down approach. We start with a general question, how do users interact with these tools? And then we focus in on what are the challenges when they're deploying these tools? And then following the flow of the SCA process, what are challenges when they act on these results? And then finally, we want to answer how can the entire process be improved? And to answer these 4 questions, we decided to talk to industry professionals like you guys. Because industry professionals or developers, you guys are the ones really interacting with the tools every day. You have a lot of exposure, different use cases you put the tools through. And talking to developers would allow us to gather a lot more experience. So we recruited 20 industry professionals with SCA tool experience. We talked to each of them for about 45 minutes in a semi-structured interview. So the structure is below here and largely follows our research questions. We start with a general, how do you use the tool? And then we move on to how you integrate the tools, then what you do once you receive outputs from the tools, and then features or measures they found useful. And then finally, we asked them what are their opinions or improvements they want to see. So after talking to 20 industry professionals, we had one main theme that tied all the findings together. And it was that along the entire SCA tool process, context really matters, and there's a lack of context in certain areas. So we discussed this in 3 aspects. The first one is there's not enough context in vulnerability alerts. So we saw from the previous screenshots that these tools will give you generic CVE information, but for users to determine if they're impacted, they need more details than that. So a lack of context from that really requires them to put in extra effort to determine the risk and impact introduced. The second aspect is depending on how you run the SCA tool, you could integrate it automatically into your CI pipeline. You could run it manually, periodically. The different methods of integrating them have different trade-offs in your development lifecycle. For example, if you run them automatically and the SCA tool generates too much noise, it could put pauses or stops in your CI pipeline, which can be annoying if it adds up. So some participants share that they transition from that to like running the scans manually. The third aspect we found was when integrating the tools along an entire supply chain or a big organization, or communicating the tool results across different teams, different parties, because different teams and different parties have different workflows, different tools they run, the communication may require some overhead. So these are the 3 main findings we found. Let's dive into our first research question a little more. How do users interact with these tools? We first started by asking users why they chose SCA tools. And the majority of them said we use them to find software vulnerabilities. Also, a good amount of them said we use them for compliance or licensing issues. These are pretty intuitive reasons. Some less intuitive reasons I found pretty interesting was a participant mentioned using them for mergers and acquisitions. So if you're buying a company, you want to know the company you're buying and what's in their software. So using SCA tools could help them identify their software stack. Another participant shared using SCA tools for export controls. So they shared that sometimes laws can be strict on the software you export, and using SCA tools can help you determine if there are certain things you can't export in your software. Then we moved on to asking participants, how do you select these tools? And the majority of them said the ease of deployment is a huge factor in selecting tools. For example, if you have all your source code or repositories in GitHub, an SCA tool like GitHub Dependabot would be really easy to integrate into all your different repositories. As compared to like you're running, say you have like hundreds of repositories, and then you have to integrate each of them into a separate tool. That would be too much effort for the organization. An interesting thing we observed was that participants sometimes also switched tools. And there are 2 main challenges that led participants to switch tools. The first one was sometimes the SCA tool had really strict scan requirements, and their engineering teams or their workflows probably couldn't satisfy the requirements easily. So they had to change their pipelines a little bit, put in additional effort so that their SCA scans can run smoothly. That was one of the reasons that they switched tools. Another participant also shared that the accuracy of the results led them to switch tools. So say they started using tool A and it would be reporting wrong components or vulnerabilities that probably weren't in their components. That would lead them to switch to another SCA tool. All right. When we were asking participants about how they use these tools, we observed 3 different inputs to SCA tools. The first one being source code. This was the most common. The majority of SCA tools take your entire application, looks at everything in there, and then it identifies software components. But this was a concern for some of the participants. Their organization probably treated code as a more highly restricted data type. And with SCA tools, sometimes you have to pass your application to an external service. So they didn't want to risk leaking their source code to another party. And the second type of input, metadata, kind of addresses that, because when you just pass metadata, you only pass package JSON files or manifest files, and you don't have to leak your entire source code to an external party. The third type of input we observed was binaries. Sometimes organizations, they acquire an entire binary from one of their suppliers, but they still have to figure out what is in the software. So they run a binary SCA scan on that. Some of the issues that came with that was participants shared binary SCA sometimes had issues identifying the correct version of libraries, or like this quote stated here, binaries, because they use fingerprinting or hashing. So if you change a single line of code or a single variable, the entire output could be different. So when you have copy pasted code in the binaries, that would sometimes confuse the SCA tool because the fingerprinting results are completely different. All right, let's move on to our second research question. What are some challenges when deploying these tools? The first thing we observed was legacy languages or unsupported scripts in the application. Participants share sometimes they use less common package managers, languages, and SCA tools don't support that. So to run an SCA scan on that, they either have to find a workaround or they go talk to the SCA vendor to see if they could work something out. The second challenge was different ecosystems. A lot of participants shared that SCA tools sometimes perform better in one ecosystem and less or worse in other ecosystems. One participant shared some insight into why this happens. It's different package managers or different language ecosystems. They have different ways of resolving the libraries. So an SCA tool has to figure out all the differences in these ecosystems and try to write code that addresses that. It's simpler when you have a single ecosystem in your application. Sometimes participants share they have multiple ecosystems or languages in their application, and one tool wouldn't be able to scan their entire application. So they try to integrate multiple tools together. But that was a really, really big challenge. One participant shared they tried doing that, but because different SCA tools work differently, they had to write like wrappers or custom scripts to connect everything together. But if an SCA tool changes or makes an update, you have to update all the different wrappers and custom scripts you wrote. So that became a very big maintenance cost for them. So it was a pretty big challenge if you have multiple ecosystems across your entire supply chain. All right. The other challenge related to deploying SCA tools is when you're integrating your SCA scan into your CI pipelines. So integrating them into your CI pipelines is efficient because they run automatically when you push code or you make a pull request, but sometimes that comes with trade-offs. For example, if the SCA tool it finds a lot of alerts and it fails your build on every single one of them, then it can create a lot of pauses or stops in your pipeline. Sometimes they can be annoying to developers because they have to go back and fix stuff, recommit the code. And if it happens too often, it could stop the entire pipeline. And one participant shared that in their case, the SCA tool stopped it so frequently that they transitioned to running the SCA scan manually, so it wouldn't halt their development pipelines. I think the challenge here is understanding that sometimes SCA tools can be noisy. They can alert you on critical, high, all the way to low level alerts. And you have to figure out which level alerts you want to stop your build or tests on. And figuring that out, and also telling the developers that the SCA scan might stop because of reasons XYZ, it would help the developers to set expectations when they push code. So let's move on to the third research question we have. What are challenges when you act on the SCA results? One of the main challenges participants shared was you receive these alerts. It could be a large number of alerts and you don't know what to do with them. Participants shared they usually have some type of prioritization method. They could prioritize by severity metrics such as CVSS scores or scores from the SCA tool. They could also prioritize with the time effort needed or the impact of the vulnerability. But really determining time, effort, and impact itself is a challenge because you would need additional context for that. So determining impact is especially hard. You would need a lot of understanding around whether or not the vulnerable libraries is actually reachable, like static function reachability, but also if your application is reachable from the network. Some participants shared they had an application sitting behind a firewall, but the SCA tool would still alert them of vulnerabilities in the application, and that really didn't apply in their case. Another aspect to determining impact was exploitability, determining if there is untrusted data that flows into the application, and if that data is sanitized before it reaches the vulnerability is also something to consider. One of the quotes from a participant really stuck out to me. So interpreting how a vulnerability impacts the application can be a challenge. And this participant shared that sometimes they have to talk to lawyers and you really have to be really clear and verify the impact of a vulnerability. But with existing SCA tool results, they were not able to clearly verify the impact of a vulnerability, and that caused a challenge for them. Once you receive all these alerts, developers have to try to fix or resolve the vulnerabilities. The most common method is you just update the vulnerable library to a newer or non-vulnerable version, but that also comes with some issues. Some participants share if you just blindly update something, you might break your software. Say if you update to another major version that could have different APIs, and that might cause a break in your software. Sometimes to prevent that or fix the breaking changes, developers share that they would have to write custom fixes or patch the code. One participant shared they took a vulnerable library, forked that, took out the vulnerable piece, and used the fork as one of their dependencies. But that took a great deal of extra effort for them. So sometimes updating or fixing vulnerabilities can be a huge amount of effort. So sometimes developers or teams, they choose to not fix vulnerabilities. It could either be The security team goes to the engineering team and the engineering team decides, this isn't an actual impact or risk to our application, so we don't fix that. Sometimes they weigh the security risk and the business risk. So say fixing this security issue would require a lot of effort and time, but not shipping your application or software would also be a huge impact on the business. So in that case, sometimes they decide, okay, we could put off the vulnerability for now and ship the software. Sometimes there's simply no alternative available for this library. We've had participants share that they work with certain suppliers and they're the only supplier in the market. So if you don't work with them, then you don't get the component needed for your software. So these are some cases where participants shared that they didn't fix the vulnerabilities. And for the last two scenarios, usually they try to mitigate the vulnerability. For example, by isolating the vulnerable component or removing network access. Oftentimes when you remove network access, no untrusted data can come in, so the vulnerability can't be exploited by a malicious actor. When we were asking participants how they act on these SCA results, we've observed different approaches between small organizations and large organizations. With small organizations, they usually don't have separate security teams, engineering teams. They have like one team that does everything. So they take in the results, they have to go through the results and come up with a fix. So it's more work on the single developer. With larger organizations, they have a lot more resources, people. So they have separate security teams and engineering teams. And they also have a lot more alerts because their software is so much bigger. So to keep up with the amount of alerts they get, some participants share that they built custom tooling that kind of pre-processes the alert results and then feeds them to the security team or the engineering team. So their pre-processing could be like finding out that vulnerability, a lot of the different vulnerabilities have the same root cause, like library A. So if they fix library A, they could propagate the results to all the related vulnerability alerts. But this requires like a separate team, and only large organizations really have the resources to maintain a tool like this. So after seeing all the different challenges, we asked ourselves, how can the SCA process be improved? And we go back to the ideal SCA scenario, where we want an SCA tool to have smooth deployment. We see some participants say sometimes integrating multiple tools can be a challenge. So deploying it would run into issues. We also want tools to identify components correctly. Some participants complained or shared that tools had issues identifying the correct versions. And with the third characteristic, alerting vulnerabilities that matter, most of these tools just alert you of all the vulnerabilities found, and they don't really have a filtering for whether or not these vulnerabilities matter in your application. And as for fixed suggestions, some of these tools provide fixed suggestions, but to really fix the alert, you update them, but sometimes you run into issues, or you have to put in a lot of extra effort to go another route to fix the vulnerability. So based on all our observations and what makes an ideal SCA tool, we came up with some suggestions for SCA tools. The overview of all of these suggestions is really to provide more context. It could be context around the vulnerable library, how it is used. For example, you could be calling multiple libraries until you reach the vulnerable library. So determining how it calls, what it calls, is the vulnerable function actually callable, would be really helpful to prioritizing these alerts. But context could also be around the main application itself. For example, what the application is built on, how does it interact with users or other applications? Is there infrastructure configuration that could affect the impact of a vulnerability? Or is the application sitting behind some kind of firewall so network reachability? If it's sitting behind a firewall, then no untrusted data can actually flow to the application. And then thinking about exploitability as well, is there untrusted data that flows to this main application? If there is no untrusted data, then the vulnerability is probably not going to be exploited. And is there like a data flow you can find to the vulnerable library? Is there sanitization of the data along the way? That's also something to consider as well. One of the quotes from a participant was very insightful. This participant said, if you combine SCA tools with SAST, that would be very helpful. So SAST could be like a call graph analysis, or you do data flow analysis. Combine that with your SCA tool, and then add infrastructure context as well, like how your application interacts with the user or other applications. All of that combined would be very helpful to prioritizing these alerts. Some other suggestions we had was, we've observed that there really is no perfect tool. There is no perfect SCA tool for vulnerabilities. Tools will always make some kind of mistakes. So one of the things that could be improved or added in SCA tools is to learn from user input. So creating some kind of feature where the SCA user can provide input to the tool. And then this could be some kind of feedback loop between the SCA vendor and the tool user, so they can continuously improve the tool. That would be helpful, so the tools don't flag future alerts that aren't really impactful to the application. As for SCA users, from all of the observations we had, we've observed that different tools have different strengths and different weaknesses. So when you're picking an SCA tool, you have to understand how that would fit with your application. Also, different teams and different organizations have different workflows, pipelines, and deployment styles. So determining how an SCA tool fits into your entire pipeline would also be helpful. And when you're trying to fix the results, it often requires communication between different teams or between your customers. So understanding that different teams and different parties have different tools as well. They have different pipelines. They also have a different context or understanding around the issue. So really understanding that, and then trying to communicate, keeping the communication channels alive so you can communicate efficiently when something happens is really important as well. So to summarize, we've talked to 20 industry professionals. We asked them how they interact with the tools, the challenges they run into, and we've observed that across the entire SCA process, a lot more context is needed so users can evaluate the impact, evaluate the risk more accurately. Also, understanding the context around the deployment of the SCA tool is really important. Different deployment styles have different trade-offs. Also understanding that communicating the results across different parties can also generate some overhead because different parties have different contexts. And to summarize, our suggestions for SCA tools is really to provide more context. Could be static function reachability, but also adding in infrastructure context, network context, also thinking about exploitability, and maybe adding in some features for users to input. All of that would really help SCA tools improve. And when you're integrating SCA tools, keep in mind that different tools have different strengths, and finding a tool that works well with your pipeline would really help so you prevent future challenges when you're running SCA scans. And that concludes my talk. I'd be happy to talk more or take any questions. A little promo for myself. I'm also trying to wrap up my PhD soon, so I'd be happy to collaborate with any research or take part in any other opportunities as well. There's also a list of some other research I've worked on, so I'd be happy to take any questions. And there's a mic over there.
Hello. Thank you, Elizabeth, for this amazing talk. It was quite interesting. I got to learn new things. I have this question related to STA tools for binaries. Can you maybe, if you are able to elaborate on that, maybe if you have some examples or some suggestions that, let's say if we have a few binaries, and which STA tools would one use, and like how would one go about?
How would one go about? I can name some tools the participants share they use. Some participants share they use like black duck tools. I believe that was the main one from our study. And relating to how to go about, could you elaborate a little bit more on that?
So you have several binaries, and they're part of an ecosystem of an entire application. You
Right.
use STA tools since you added infrastructure context. How would one use STA tools to maybe see that this binary is communicating to this binary? And maybe if this binary is vulnerable, then maybe through this, another binary could also be vulnerable in the entire ecosystem.
I think that's something that's lacking from SCA tools currently, because they analyze a single software or a single binary, and it lacks the interaction between different results.
Okay, so you're saying they work in isolation at the moment, but it would be nice if they worked in conjunction with other.
Yes, that was part of the infrastructure context. We think that would be helpful.
Okay, understood. Thank you.
Thank you.
And we do have a question from a participant on Discord. Christina Haig asked, have you communicated your report back to the SCA vendors you evaluated? And if so, what feedback did you get?
We have not talked directly to SCA vendors. Okay, let me correct myself. I've talked to some SCA vendors and I've shared our results with some of them. But I haven't received much feedback from them. They thought it was an interesting research, and that was the feedback we got from them.
Okay. Great, thanks. Questions, other questions in the room? Plenty of time. Right, seeing no further questions. Elizabeth, thank you very much for your presentation. Much appreciated.
Thanks very much.